Alright, welcome to the video on the unit circle and the left-hand trick. In this video I'm going to teach you a trick to help you memorize the unit circle, which we use in trigonometry, and I'm going to teach you the left-hand trick. Alright, the basic idea is we're going to use our left hand to represent the unit circle, or more specifically, just the first quadrant of the unit circle. And we can do this palm down or palm up. I'm going to do it palm down in the diagram. If you do it palm up, everything kind of reverses, but your thumb in the palm down position represents 0 degrees. Or if you're going in radians, we'll do 0 radians. Your pinky is going to represent 90 degrees, and if you're doing it in radians, that's going to be pi over 2 radians. From there, each finger represents a different angle. So the first finger is your 30-degree angle, the second finger is your 45-degree angle, and then the third finger is the 60-degree angle. And these are all in degrees, and we can convert them to radians. The 30 degrees we know as pi over 6, 45 we know as pi over 4, and the ring finger represents pi over 3 radians. So what we have is a hand that approximates the first quadrant of the unit circle, and we're going to turn in various fingers to do calculations. So this is the basic idea. We're going to be counting fingers, and we can use this to evaluate trig functions. So I'm going to take this and put it in the upper corner for reference. And let's say we wanted to evaluate sine of pi thirds. So what I'm going to do is I'm going to take my hand and I'm going to turn in the pi thirds finger. Okay, so what we've got here is our pi thirds finger is turned in, and to evaluate sine of pi thirds, we do the lower fingers. So the total count of the lower fingers is we have 3 fingers below there. So sine of pi thirds is equal to the square root of the lower fingers all over 2. There we go. All right. Let's do the same thing. This time we're going to let's do cosine of pi fourths. So what I need to do is I need to turn in my pi fourths finger. So in this case, the middle finger is my pi fourths finger. And for cosine, we take the square root of the upper fingers. So for upper fingers, I've got 2 fingers above the angle, so my answer is the square root of 2 over 2. So cosine of pi fourths is equal to root 2 over 2. If we were to check out what sine of pi fourths is, using this same angle, we count out the square root of the lower fingers over 2. So lower fingers is going to be 2 as well. Alright, let's say I needed to find tangent of pi sixths. So with pi 6, I'm going to need to turn in my pi sixths finger. There we have the pi 6 finger turned in, and we know tangent to be the value sine over cosine, so we can also treat this as the square root of the lower fingers over the square root of the upper fingers. So the square root of the lower fingers divided by the square root of the upper fingers, and there's 3 of them. So tangent of pi sixths is equal to root 1 over root 3, which if we rationalize the denominator, we wind up getting some value like root 3 over 3. But the hand trick does not rationalize denominators for us. So make sure that if you need to rationalize the denominator, you move forward from there. Okay, Let's look at some peculiar cases from here. Some students would argue that the hand trick, or some people think the hand trick only applies to those three angles. But let's take a look at what goes on when we take a different angle than those three. Here's sine of 0, and if we drop in our hand, we can tackle this task. Alright, so our angle is 0. So in this case, we're out here at an angle of 0. And if you remember, sine is the square root of the lower fingers. So we have no fingers underneath this line. So what we have is the square root of 0 over 2, which is 0. Thus, sine of 0 is equal to 0. If we wanted to know what cosine of 0 was, cosine of 0, we're going to count the fingers above. So in this case, we have 4 fingers above, so we do the square root of 4 over 2, which happens to be 2 over 2, which is 1. So cosine of 0 is equal to 1. And then finally, if we did tangent of 0, we do tangent of 0 is equal to the square root of the fingers below over the square root of the fingers above, and we wind up getting 0 halves, which is 0. So the hand trick works for our quadrantal angles as well. Just a real quick other quadrantal angle, sine of pi halves. Here's our pi halves finger pulled down, so we know that this is pi halves, and sine is going to be the square root of the count below. So we start with the square root of 4 over 2, and it's always over 2, which when we reduce it is equal to 1. So sine of pi halves is equal to 1. But what about angles outside of the first quadrant? What about those? Does our hand trick work to evaluate things like sine of 7 pi over 6? You betcha. In order to do this, you have to memorize another detail, and that's the sine, as in S-I-G-N, sine of various trig functions in various quadrants. So there's this handy chart here. Some people might refer to this as another stupid trig chart, or the more positive outlook, all students take calculus. But what that means is all 6 trig functions are positive in this quadrant, and in this quadrant only sine is positive, in this quadrant only tangent is positive, and in this quadrant only cosine is positive. So what we have here is sine of 7 pi sixths, and if we were to graph that out, we know that 7 pi sixths is somewhere over here. So what functions are positive here? Only tangent. So we know that this answer is going to be negative. And once we've established that, then we can turn to our hand trick. So we use the reference angle for 7 pi sixths, and the reference angle for that is pi sixths. It'll always be the denominator if you reduce the fraction. And we just run the hand trick off of pi sixths. And we know sine to be the square root of what's below. So for us, that will be the square root of 1 over 2. And we know that the answer needs to be negative. So we plug the negative in there, and we get a final answer of negative square root of 1 over 2, or very simply, 1/2. That's our final answer. All right, we'll do one more here. Tangent of 3 pi fourths. Well, first off, we want to know what the reference angle is, and 3 pi fourths is located here, and in this area we know, another stupid trig chart, we know that only sine is positive. So Therefore, this answer is going to be negative, equals negative something. And let's use our reference triangle, or a reference angle. In this case, the reference angle is pi fourths, and we'll use our left-hand trick. Alright, we've got our left hand representing the first quadrant from 0 to pi halves, and our reference angle was pi fourths, and we know that tangent is sine over cosine, so we take root of the values on bottom divided by root of the values on top, so root 2 over root 2, and this simplifies to negative 1. Therefore, tangent of 3 pi fourths is equal to negative 1. Okay, some quick tricks on deciding whether to count up or down. So, say we were doing pi thirds, and we wanted to know whether we should be counting our fingers underneath or counting our fingers above the line. So, one thing that you can think about is we're going to do this alphabetically. Cosine starts before sine, so that's one look at it. The above functions are the cosine ones, and the below ones are sine. Another approach you could take is the cosine function. We know when we graph cosine of x, we start at the top and work our way down. So with cosine, we start at the top and count downwards, as opposed to when we graph sine of x, with that graph we start at the bottom and work our way up. So we would start at the bottom and work our way up, counting wise. Those are the two tricks that I know how to remember whether I want to be counting down or up. And then for tangent, I always think of tangent being equivalent to sine over cosine. So for that reason, I will take the bottom fingers and count them over the top fingers and count them. One last note. This is a very useful trick for common angles. However, this trick is going to fail us when it comes to more obscure angles like sine of pi twelfths. We don't have an answer for that. Sine of 18 pi sixths. We want to be careful, even though this has a denominator of 6, after we reduce the fraction, we find that this is actually sine of 3 pi. So this one is a quadrantal angle. So we can use the hand trick, we just don't want to use it for the pi sixth finger. We actually use it for the pi finger, or the 0 finger. Okay, thanks for watching. I hope this helps you memorize the unit circle. I'll throw down one more example for kind of one of the non-quadrant 1 angles for you to practice on if you need to. Alright, the angle is 5 pi thirds, and we want to know cosine of 5 pi thirds. So, plotting that out, we have 1/3, 2/3, 3/3, 4/3, 5/3. So there's our angle, and from that chart we can take the ASTC, and we find that in this quadrant cosine is positive. So we put down our hand and we grab the pi thirds finger and pi thirds here, and then cosine we read from the top down, so we're counting the fingers on top. In this case we have one finger, so the square root of the number of top fingers always divided by 2, and there's our answer, 1/2. And then we check whether we've got the right sign. Yes, we do. Cosine is positive in the 4th quadrant. So cosine of 5 pi thirds is 1/2. Alright, hope this helps. And as always, thanks for watching.